Hello everyone, I'm Paul and today we're solving problem 3346, maximum frequency of an element after performing operations 1. This is medium with different possible solutions, and here I will show you what I think it's a very intuitive one. So let's start. We are given an integer array nums and two integers k and num operations. So let's say this is nums, k is 2, num operations is 2. And we need to return the maximum possible frequency of any element after performing this operation num operations times. And the operation goes as follows. We need to select an index that was not selected in previous operations and add an integer in the range from -k to +k. So let's say we are trying to get all number 6. We can choose this number and subtract 1 because 1 is smaller than k. So we subtract 1, the new number is 6. Here we can subtract 2, the new number is 6. By doing this, now we have 3 number 6. And this is the maximum possible frequency of any element that we can get. So we return 3 in this case. Another possible solution is we can add 1 here because k is 2, so we can add 1 here, the new value is 7, and we can subtract 1 from here, the new value is 7. Now we have 3 equal values. This is the maximum possible frequency, so the result is the same. And we need to add or subtract a number in the range from -k to +k. So we could add a 0 here, for example, and we would keep 6. Now here we have the constraints, and we know that everything can be up to 10 to the power 5, and this means we need to think in terms of something better than n squared. For example, we can think in terms of n log n. And there are different solutions to achieve this, but next I will show you what I think it's a very intuitive one. Let's say we have the same input. Remember that for the result here, we are taking a number that we already have in the array, and from this number we get the result. For example, if we pick 6, we transform these 2 into 6. We can pick 7 also and transform this and this into 7, or we can pick 8, okay? Now, let's say we don't have this and the array has only these 2 elements. Here, the target number is not included in this array. We have 2 operations available, so given that k is 2, we can add 2 here, the new number is 3. We can subtract 2 from here, the new number is also 3. So in this case, the result would be 2, and the target number is 3, and 3 was not included initially in this array. So this is the main observation. The target number could be in the array or not. And with this in mind, we can try every number from the minimum number, from 1, to the maximum number, 8. So in this case, we are trying all of these as targets, 1, 2, 3, 4, 5, 6, 7, 8, okay? So if we take 3 as a target, we can reach 3 minus 2, meaning we can reach 1, or we can reach 5. Okay, so we can reach these 2 elements. So if we pick 3, we can get 2 equal elements in this case. And if we take 6 as a target, we can reach 6 minus 2, 4, and 6 plus 2, 8. Now the thing is, we only have 2 operations. So we can reach all of these numbers. And we are taking 6 as a target. So first we need to get the frequency of 6, because here we only have 1 6, but it might be a case that we have many number 6. And in this case, we are not using any operation for this number 6 because they are already 6. So we need to know how many numbers of the current target do we have at each point. And for this, we can use a frequency map. And in case you don't know what a frequency map is, we are iterating this from left to right. So first we are here. We add 1 as a key, and the value for this is 1. What this means is up to this moment we have seen number 1 only once. Next we continue here, we add 5 as a key and the value is 1. Next we are here, we add 6 with a count of 1. Next here we add 7 with a count of 1. Finally here we add 8 with a count of 1. And something I forgot to mention is that we need to sort this. This is very important. So let's say we pick 6 as a target again. We can reach 4 and 8. And what this represents up here is we can reach all of these numbers. And given that 6 is the target, we can take every 6, which is only 1 in this case, and remaining elements, meaning these 3, is the maximum number of operations that we could do in this case. So we can do up to 3 operations to get all equal numbers, in this case 4. Now the problem is that the number of operations is 2. So in this case the result will be the frequency for the target, which is 1, plus the minimum number between the operations that we can get and the maximum number of operations for this case. In this case we can only make 2 operations, so 1 plus 2 is 3. So if we take 6 as a target, we can get 3 equal elements. For example, we could replace this with 6 and this with 6, or we can replace this with 6 and this with 6, okay? We can get up to 3 equal elements in total. And the final question here is, how do we get these 4 elements? Because here we know that we can reach number 4 from 6. But how do we know that this left bound corresponds to index 1 in this array? And maybe you're thinking about trying a linear loop, but this is very inefficient. We need to think about something else. And for this we can use 2 binary searches. First, we are using 4 as a target, and we run a binary search left in this array, so this will return index 1, meaning this left bound. And next we run a binary search right in the same array with 8 as a target, and this will return index 5, meaning this right bound. So how do we get the number of elements in this subarray? Well, we do the result for binary search right, which is 5, minus the result of this binary search, which is 1. This is 4, and what this means is here we have 4 elements. And once again, remember, it's very important to sort these elements. We can run binary search in sorted elements. So we have 4 elements, we subtract the frequency for the target, meaning 1, we only have 1 6 here. The result for this is 3. 4 minus 1 is 3. And this means we can run up to 3 operations in these 4 elements, and the minimum between 3 and the number of operations is 2. So for this example with 6 as a target, we return 2 plus the frequency for 6, which is 1, we return 3, okay? So let's go from the start. We need to iterate this from left to right. We are trying every one of these numbers as a target, so first we are here. From 1 we can reach -1 and 3, okay? So we run a binary search left with -1 and a binary search right with 3. For the first binary search, the result is 0. So we go from here to the result of binary search right, which is 1, okay? And here we have 1 element in total, and we need to subtract the frequency for the target. The frequency for 1 is 1, and the result for this is 0, meaning we already have our target. We only have 1 element, and this element corresponds to our target, so we are not doing any operation here. And in this case we return the frequency for the current number, which is 1, plus the minimum between number of operations and the maximum number of operations, which is 0, so we return 1. And the maximum between 1 and the result is 1, so we replace this with 1. Now we are here, and from 2 we can reach number 0 or number 4. I mean, we can reach every number in this range. So we do the same. We run a binary search left with 0 as the target, and this will return index 0. So we go from here to the result of binary search right with 4 as the target, meaning index 1. And here the result for right minus the result for left is 1. We have 1 element in total, and we subtract the frequency for the current target. Here we don't have a 2, so we subtract 0, and this is 1, meaning we can take up to 1 operation to transform this one into our target. And in this case we return the frequency for the target, which is 0, plus the minimum of num operations and the maximum amount of operations that we could implement. In this case, 1. So we return 1, and the maximum between 1 and the result is 1, so we keep 1 here and continue. Now we are here, we can reach 1 and we can reach 5. So we run a binary search left with 1, and the result will be index 0. And binary search right with 5 will be here, index 2. So now we have 2 elements, and 2 minus the frequency for the target, meaning 0, we don't have the target here. This is 2, meaning we can take 2 operations as a maximum to transform these 2 numbers into a 3. Okay, so in this case we return the frequency for the target, which is 0, plus the minimum of 2 and 2. The result is 2, and the maximum between 2 and the current result is 2, so we replace this with 2. Now we are here, 4 minus 2 is 2, so we can reach this point, and we can reach 6. Binary search with 2, here we return index 1. And binary search right with 6, we return index 3. 3 minus 1 is 2, meaning we have these 2 elements now, minus the frequency for 4, which is 0, this is 2. And now we can return the frequency for 4 plus the minimum of 2 and 2, which is 2. This is 2, meaning we can use 2 operations to transform these 2 into 2 number 4, and the maximum between 2 and 2 is 2, so we continue. Now here 5 minus 2 is 3, and 5 plus 2 is 7. Binary search left with 3, we return this, index 1. And binary search right with 7, we return index 4. Here we have 3 elements, minus the frequency for the target, which is 1, this is 2, meaning we can replace these 2 elements with 5. So we can take up to 2 operations as a maximum, so we return the frequency for the current element, which is 1, plus the minimum between 2 and 2. And the result is 3, and the maximum between 3 and the result is 3, so we replace this with 3. Now here we do the same, we can reach 4 and we can reach 8. So binary search left with 4, we return this, index 1. And binary search right with 8, we return index 5. 5 minus 1 is 4, meaning here we have 4 elements, minus the frequency for the target, which is 1, this is 3. So we return the frequency for the target, 1 plus the minimum of the maximum operations, the maximum number of operations that we can run, and num operations. This is 2, so the result is 3, the maximum between 3 and 3 is 3, so we continue. Here we do the same and the result is free. Next here we do the same and the result is also free. So the maximum number that we can get is free. We return this. So this is the entire approach. Here time complexity will be big O of n log n, mostly because we need to sort this, plus we will say this is m log n. M is the amount of elements in between the minimum and the maximum elements in the array. Remember, we are trying each of these targets, and every time we run a binary search on this array. So this is overall m log n, this is overall time complexity, and space complexity will be big O of n. Remember, we have a frequency map here, and also space for sorting in Python requires big O of n. So this is it for the approach. Now let's go with the code and hopefully you will get the idea. First we need to sort nums, so nums.sort, and we are building a frequency map, so we are using a default dictionary with a default value of 0 for every key. And now for every value in nums, frequency map at the current value plus equal 1. Now we are building a function. We will call this get frequency, and we will use a target every time. And we are running two binary searches here. First one to get the left bound, which is bisect left in nums, and the target for this is the left bound target minus k. And we are doing the same for binary search right. So bisect right in nums with target plus k as the target. Now the maximum number of operations that we can use at this point is the total amount of elements, which is right minus left, minus the frequency for the target. If the target is in the array, we subtract the frequency. If it's not in the array, we get 0 here, so this is fine. And now we can return frequency map target plus the minimum of the maximum number of operations and num operations. And now with this function we can say result is 0, and for n in range from the minimum value, meaning nums 0, to the maximum value, nums minus 1 plus 1, because this is included. And every time result is the maximum between the result and get frequency with the current number. Finally, we return result. So this is the entire code. I think this is right. Now let's submit this and see if it works. This is target, so let's fix this and try again. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.